So for bad presentations, I'll try one. Again, as Johannes said, we haven't yet learned very well how to present. So that's the first time I'm giving this talk. And first of all, I'd like, again, to thank all of you, especially Amplify, that gave us the space to do this. It would have been very hard without the help. So thank you. Thank you for coming here. And I'll start. So the presentation is called Y Effect. This slide comes from the State of JavaScript survey from last year. And this is asking people what they feel is missing from TypeScript, from JavaScript. Getting a little bit ahead of myself. If I read this slide, I read static typing, I read standard library, which is a weird name, better date management, guess a lot of people had problems with moment, immutable data structures, that's interesting, observable, good, pipe operator, decorators, opinionable, and pattern matching. Does this reflect any of you? Like, you've used JavaScript for a while? Okay. It's funny, because this reflects exactly my ideas, and I'm getting, again, a bit of ahead of myself. Hi, I'm Mike, kind of love TypeScript, or rather grown to love TypeScript, and I've built Effect, and now I'm gonna try to tell you why. So why Effect? The slide before, we saw quite different names on that slide, and with Effect you do get immutable data structures, you do get type safety for errors and requirements. You get structured concurrency, you get observability. And later on, we're gonna see most of those things in a concrete app. Especially observability is something that can be obscure to many, because it's sort of a recent pattern, but it's one of the things I love most about Effect. Effect gives you indeed pattern matching, if you want to. Gives you interruptibility and resource safety, modularity, composability, and it has a rich ecosystem of integration. It's kind of the missing standard library from TypeScript, or at least I like to think of it in this way. Well, let's take a little bit of a detour into JavaScript, which is really what backs the runtime of all of this. JavaScript debate, this slide could be way longer, but I sort of kind of summarized it in a few points. It's a very old language, well, very old, relatively old, can drink beer, pretty much all the word. It didn't really have modules, because it was meant to run in a browser, to build scripts, so it didn't really need any modular architecture at the beginning. Was definitely not designed to scale, and never had a standard library. Like, if you see any other language, there's the language runtime, and then you have a rich standard library of functionality that you can just plug into your program and use. If I think of Go, the standard library is extremely rich. Rust, the same. JavaScript, no standard library whatsoever. And it kind of have an awkward behavior in many things. And that's one number plus one string can yield whatever. A equal B might be true or false depending. It's kind of a mess. But has evolved. And here we can kind of see a timeline of some of the important steps. This as I see them. Starting from the very beginning with creation of JavaScript, meant to run in browsers. So funny enough, it's one of the languages with a better specification and with multiple independently developed runtimes since day one, because we've always had multiple browsers. But it took a few years before somebody, ARNALDI in this case, decided to try and use JavaScript in the backend. With the creation of Node.js, that sort of marked a very important step in the development of JavaScript. That's where first concepts like modules and really what JavaScript is today kind of born, with NPM and the ecosystem of modules. Another very important step is, to me, the creation of TypeScript by Microsoft. That's 2012. Then we've got React, 2013. Dino as a separated runtime, very recent. Now, a year ago, Ban. Like, JavaScript is evolving. It's becoming a beast. It's becoming amazing to use, and you can do way more than what it was thought to work with. So JavaScript, the good, because there's also a lot of good. It is asynchronous and event-driven. Its concurrency model is really great. It runs everywhere, pretty much everywhere. I've already mentioned Node.js, Dino, and Ban, but there's more. There's tons of embedded JavaScript runtimes, and it truly runs on an amazing number of devices. Has a rich toolchain. As much as we like to complain about the toolchain of JavaScript, it's one of the best I found in many other languages. Not the best. Hands down, it's messy sometimes, but it's by far not the worst. Again, I've mentioned the concurrency model, which really fits business logic, really fits problems from the real world, and can disembowel it, so it can really run even. I've even seen implementations where you embed a WASM runtime in the browser and you run JavaScript embedded in an embedded sandbox, which is amazing what you can do. This is a tweet from a friend of mine who happened to be the author of Zio. Zio is a Scala library, targets the JVM. This person was a heavily parallel advocate and has tweeted this year, and was like, I have to screenshot this. It's taken me a decade, but I think high-level languages not made for writing operating systems should provide green threads atop of a single OS thread, which is almost JavaScript. Not really, but almost. Concurrency is great, but 99% of the problems don't need it in the form of parallelism. Effect is precisely that. It gives you green threads, gives you fibers on top of a single execution thread, which is the event loop of JavaScript. And he did admit, which is almost JS. But with Effect, we really consider JavaScript and TypeScript to be the same at the moment. Why? Because TypeScript is really the reason why JavaScript is usable at scale. Microsoft has a unique capability in dev tooling. The dev tooling around TypeScript is just amazing. It's really just JavaScript with types, the sense that they did not reinvent a new language. It's widely supported by pretty much any tool I can think of today, and it's one of the most advanced and complete type systems that I've ever had to work with. And I've worked with quite a few type systems. If we see during the years another slide that I took from the state of JavaScript is how many users are now using TypeScript fully. That's 20+% of the full JavaScript usage base, which is huge. And most importantly, you see that it's not like if you see 100% JavaScript against 100% TypeScript, there's almost no gain. And even people that don't use it for everything still use it for 75% of the things. Like, this part takes 40% of developers in the JavaScript space. So it's a language that we can use reliably. It's heavily used in production by many people, and it's a great basis to begin working on. So what do we target with Effect? Well, we target pretty much everything you can build with JavaScript. We target single-page applications, multi-page applications, a very interesting, another type of applications that are called local first. Johannes is gonna give a talk about how he built a local first app after. It's extremely interesting. Can be used for backend APIs and middlewares. It's actually the first reason I've created Effect was to deploy a backend. So it was to be used in a backend. You can develop full stack apps. You can use it with React Server components. You can use it with Remix. You can use it with Next.js. You can use it quick. I will demo in a few minutes a Remix integration where we're going to go step by step. You can use it for serverless, like Lambda functions are ruling the world. And it's perfect for writing business logics and workflows. Right? Even very widely used workflow platforms, we see the first language used, TypeScript. We want to get there. So let's see some code. That's enough for slides, and I'm bad enough, so I'm slightly better to code. So I've prepared for you a demo that hopefully it's gonna all work. I am using Remix as a framework, as I've described before, and we are gonna start with
make it bigger.
Make it bigger. Thank you.
Like 3 more. Bigger.
Bigger again?
Yes. Bigger.
Theo, come up. No, that's too big.
That's perfect. That was great. Go up 1 more. I stream at 720p for a reason. Go up 1 more. Perfect. There you go.
Okay. It's gonna look fun with the effect side. Yeah. So let me maybe show what this beautiful app is doing. Oh!
Bigger. Come on, fellas.
Well, you're not gonna understand it anyway, that's the point. Okay, this error sucks. Let's try again. Oh, it works. My graphic skills are close to none, so you gotta have to deal with white interface. But once I'm here, I can hopefully create a to-do. So hi, let's see if it works. Oh, come on. So what is happening here behind the scenes? Well, this error is close to useless for how I see things. And that's the user experience when something goes wrong and you're not using Effect. So what is going wrong is that this is a normal TypeScript app. As you see, the Effect is not even imported. It uses SOD to do data serialization, and it uses SQLite to persist data locally. What the app does, you've seen it, is it's a simple index page, and I'm gonna skip the details if you don't know Remix of how it works internally, but Remix fundamentally has two things. that you export on a component, apart from the component itself. Those can be an action, which is like if you post on the page, or there's a loader which gets called before rendering a page. It's very similar to Next.js and other UI frameworks. So we can drill down from here, and it's really hard to understand what's going on, but I can show you where the error is, because I wrote the error, so I kind of know it. Inside this getAllToDos function, it's randomly failing. Obviously, I've made the random failure because it's pretty hard to simulate a failure with a local database. But in real life, when you're using real databases, that's happening. It's gonna happen all the time. So here we are throwing an error, and I found it because I know it was there. It's really, really hard to debug it from purely looking at the code base. Here we can follow what's going on in the code base. So we can see there's an action that takes a request object. It's deserialized using Zod as an input to get which action we are using. That's a pattern common in Remix. And we're switching on which action to take. Based on that, actually do something. And the loader simply loads up the to-dos. So that's Remix without effect. But let's say that we are not so satisfied with this kind of observability. Like we have to console log. Right? Now I knew where the error was. If you don't know, usually you resort to a number of console logs. Who has ever wrote a console log to debug an error? Okay, not alone. See? One of the beautiful, innovations of the last recent time, I don't precisely know when the concept was first introduced. It's called observability. Now, in today's terms, we call it OpenTelemetry, and it's mainly composed of three things. The first one is the deer logging that we all do. Sometimes, even I debug with console log sometimes. The second one is metrics. Also, many people are familiar with metrics. Metrics, you can think of them like, for example, counters in your application that you increase or decrease based on traffic, whatever you want to tune into, and they're usually exported to either Prometheus or other systems. You probably are familiar more with Prometheus, but OpenTelemetry, which is a new library to handle telemetry, includes metrics. The third piece, which is to me the most refreshing, is called tracing. And with tracing, what we aim to is to decorate our program with metadata, with additional information that we can render on an interface and show exactly what's happening and where. If you think of a program, this endpoint, this app, in the moment I refresh, there's a loader who's been hit. The loader calls to another function, which may be called to a third function, and so on and so forth. We would really like to visualize the whole tree. And that's totally possible. And now we are going to see how to do it without effect. Hopefully it's not going to be that nice. Or at least I don't like it. So I have beautiful branches. This, by the way, is a project on my GitHub profile, so hit Mike ARNALDI and you're gonna find it.
I'll hold your mic this way a bit faster.
Faster? Ah, in typing, that's right. without effect and auto. So let's see let's see why the thing became a bit better. I'm not gonna yet show the code, but I'm gonna show the result of running it. Okay, it's failing intermittent, now it's no longer failing. Amazing. Okay, we have a few failures. And I have an account in Honeycomb. Honeycomb is a service that allows you to push metrics and telemetry to see it. There's many other services, there's open source ones, there's products such as Datadog and many more. I kind of like Honeycomb to do the tests myself because it's extremely easy to use. Here I see a few calls. Let's explore one. With you? We've called the index loader and we've called get_todos. Index loader took half a millisecond and get all todos took 0.1. And there was no error here. Let's check for something that had errors. And see, okay, we have quite a few, let's say in the last 10 minutes. Okay, we have 8 traces with errors. Let's analyze one of them. I see red, which usually means something bad happened. And I can pretty much see, okay, there's a message, error fetching todos. So this is kind of helpful to know where the error originated. But you might ask, why are we seeing only 2 things? Because now I'm going to show you how long does it take to add one of those. So in code, what I have added, so UI code looks exactly the same, nothing has changed. The loader code has changed. The loader code first was one line, was just calling the other function. Now the loader has to talk to something called a tracer, which you gotta know of. You gotta call start span to begin one of those entries that we've seen in the UI. So this is a span, and that code is what generates the first one, the top one we see here. So this is the loader code. Then I try catch. I try to get the todos. If I fail, I check if E, so the error is an instance of error, I set the status code to error and I add a message. As a last thing, I rethrow, and in any case, either failure or success, I end the span. And you see that I also pass the span as an argument to this getAllTodos function that does the same thing again, wraps everything in a try-catch, starts a new span, but this time, if the parent is present, sets the parent to the specific span that was passed in, and this is what allows you to see this relationship. This getAllTodos is a child of the index loader. I ended up here because I don't like to write my code in this way. I don't like to have all my functions wrapped in try-catches that have absolutely nothing to do with business logic. I don't like my code to talk about telemetry in specific terms. I would like all of that to be, worst case, one line of code. And hopefully, I'm going to show you how to do this, the same thing with effect, and adding telemetry and error handling, which, by the way, we're not doing here, because if I were to add error handling, I would have to add further try catches, and then, again, I really don't like that, because they lead to indented code and they lead to very hard to maintain and read.
So while Mike is pulling up the other example, anyone here already using OpenTelemetry for your app? You instrument painstakingly yourself? Okay, cool. Anyone who wraps all their code in try catches like very diligently? Alrighty, yeah, my condolences.
So you're actually using try catches? Okay. So first of all, let's see what this looks like if we are using effect compared to if we're not using effect, and then we're gonna integrate telemetry on top. First of all, here UI code, exactly the same, unchanged. What has changed is now we would like to define the loaders and the action using effect. In this case, I'll start from the loader, which is the thing that we saw before. In this case, we are declaring that this is an effect loader. This comes from the Remix integration. You find it in the repo. And this function is what configures the whole context of run the effect. This returns a normal promise to the outside. So for Remix, it's like effect doesn't exist. And here we are accessing the get all to-dos procedure from our to-do repository module, which before was just a normal import. Now we are using the effect context for this to be testable and more modular. We are accessing the get all to-dos function. We are, this yield star is like mentally mapped to an await. So this is like async await, async await, async await. We are calling the get to-dos, getting the result. And differently from what we've done before, this time we can use schema to encode the to-dos for the front end. Because schema, it's library from effect to handle data modeling. It's a lot inspired by Zod, the one we were using before. As you see, the syntax doesn't change too much. But what it allows is bidirectionality. With schema, you can both encode data and decode data, while with Zod, you can only decode the data. So in this case, we're saying, okay, to-dos may have structured information, such as, for example, data objects and stuff like that. We want to encode it for the front-end usage, and we see that this loader function precisely returns a promise with an array of simply structured, no crazy types. We see created at, used to be a date, now it's a string. And this type safety is passed to the front-end code. So this is how we would look to write an effect app in general with CN action, just we did before. Remember the action, we had to decode the payload of the action from the input of the request. Here we do it with a function that we wrote on purpose to do that. And here we have our beautifully decoded type. We branch on the actions and take the according action based on the input. So this code, while being a bit more verbose, because we have to be sincere, it is a bit more verbose, it looks almost one-to-one from the previous one, provided that you mentally map async await to generator plus yield star. So let's see now how I would, first of all, let's check that this works. It does. I have the same error as before, which is a bit more clean now, has removed some of the mess from the original stock trace. It's not yet perfect, but it works pretty much the same way as it was working before. So let's see how would I go about integrating telemetry on top of this. Remember before we added a span to the loader the span was called index loader. Okay, if I had to do it using effect, what I would do is I would call effect dot with span index loader, and that is it. That's the thing you have to add. No try catches, no nested indentation, well, a bit of nested indentation that we'll now see how to remove, but it's as easy as writing function call. If you don't like indentation, you can use the pipe method and pass the same function inside the pipe. This is very useful when you have to compose multiple actions. Now, pipe simply means function application to the prior argument. It's a common pattern that was initially thought, I guess, in either RxJS or FPTS first, and now even popular libraries such as Zod has a pipe method, and hopefully at some point in time JavaScript will get a pipe operator where we can cancel this additional pipe method. But up until that point, it's pretty decent to use. So let's skip a little bit more ahead, and I want to show you a version of the same app that uses tracing in full. We've added a few with spans around the app. For example, this loader pretty much looks like the one before. I think I've OCD'd a little bit on how to write this portion. I've changed it probably 510 times, but doesn't really matter much. We are fundamentally wrapping any operation with a span, just because we want to visualize everything, and because adding one line of code is way less intrusive than adding a try catch plus everything else. Let's see. Side of this, note I've clicked and it took me to the implementation, which was nice. There's another element that I've spoken about before when mentioning telemetry. Those are metrics. Effect has native integration with metrics, so you can define, together with spans, also the metrics. Now we're going to run the application and see the application with tracing, see what we would visualize in a normal run. Okay, still same error as before, with a little bit more context this time. You see that we added 2 entries to the error description, to the error stack. Those are the spans that we declared on code. So now we can, just by looking at the code, easily know that, okay, this comes from an index loader, this comes from the get all to-dos, and hopefully if the trace is right, if the stack trace is right, you're going to get a pointer to the exact location where the error first occurred. Of course, can also go well, and If it goes well, there's no error, but this time I want to check again the span. I'm going to do the same as I did before. I'm going to search by name. This case, no, first I did a search by error, sorry. So let's search something that has errored. Let's take the last. And okay, here we see a few more things than we saw before, because it was easy to instrument. So in my very lazy 2 days of working on this demo, I've managed to trace the full application instead of just half a function. We can show the error from here, and it has a bit more context than before. So the status message gives you exactly the error that was raised. So let's now do something about that annoying error, because I don't think you like your apps to be unreliable, do you? You like to see errors? No. No? Good. Neither I. I hate when pages crash in this way. So we add error management. What have we added? Well, to the imputing place where the error was rows, we've added 2 lines of code. Not 1, 2. Why? Because we wanted also to add another span. So adding a retry is as simple as adding 1 line of code. So we wrap the procedure that's supposed to fail, well, that's not supposed to fail, but that we know will fail at some point in time. We wrap it with effect.retry, and we give it a retry policy. In this case, the retry policy is going to be an exponential backoff curve composed together with a timeout. So this will keep retrying according to an exponential backoff curve up until the point we've reached 3 seconds. And I could add further complexity in here. You don't have to go as complex. You can say schedule.retry up to, recur up to, and there's a full module of functions that you can use at your own discretion. For API endpoints, usually exponential backoff is what you want to avoid abusing the faulty API endpoint if it keeps failing. So you should retry as fast as possible at the beginning, but only slow down if the errors keep happening. Because it's fairly common to fail 1 HTTP request, it's fairly uncommon to fail 10 consecutive HTTP requests when the backend is just fine. When the backend is degraded, very possible, and you should not keep hitting the backend, otherwise it'll degrade further. But that's the only thing we had to add. Let's check our application now. If this keeps happening, no. Now I'm gonna keep refreshing, and the UI is good. So, hi.
Might just be marked on random beam, not random.
Hi, San Francisco. Hi. Everything works. Yes. Let's see. Let's see from the traces. Let's see from the traces. Wow, we have a trace with 21 spans. It means things really, really failed. Almost. Just got in time. Actually, I think this, still 0.3 seconds, so not quite hitting the timeout, but we can already see the beginning of this retry curve. That's the nice exponential. Now I'm gonna do something live, which hopefully I don't crash everything, or hopefully I do. I'm gonna increase the error rate like crazy. Say if math.random is greater than 0.1. I don't know why I keep closing the terminal, these auto reloads. It's just me being used to do this manually for half of my life, but Beep is great and you don't have to do any of that manually. Let's check this interface again. Oof, taking a bit long. Oh. Sometimes it's fast, sometimes it takes a bit longer. Come on, come back. No. It's too random, but it's still gonna make the point. I'm gonna show just last trace. Good, that failed 12 times. And here you have your beautiful exponential back-off curve that doesn't kill your backend while making your app way more reliable. So hopefully that was the demo code. Thank you, Johannes, for having provided an ARM. And that's a fact. Now I'm gonna leave the microphone to Johannes, which is most likely going to show you a slightly more complex version of an application. Thank you, everybody.